Now the first theorem, we are going to start the first theorem. That is principle of homogeneity. Now what is the principle of homogeneity? The principle of homogeneity states that the two dimensions which has the same dimension, which has the two, or you can say the two physical quantities which has the same dimension, they only can be added or subtracted. Simple. Okay. The two physical quantity should have a same that are added and subtracted. So that is called as a principle of homogeneity. Any doubt? So only the quantity which has the same dimension, it's a normal law of addition. See, if I give you 2 kg of mango and I give you 2 Newton of force, can you directly add them? No, because they are two different quantities. That is only the same. If we have a same if we can add only two physical quantities together when, or subtract together when we have a same dimension. That is a simple law. There is nothing so much complex is there. Whenever we have a two same physical quantities which having a same dimension, they can be added and subtracted easily. For example, like you remember one formula, S is equal to U half a t square. Let's find the what is the dimension of S? S dimension is L. What is the dimension of UT? What is the dimension of UT? LT minus 1 into T. That will be how much? Again it is L. What is the dimension of half a T square? See, half is constant. For a constant there is no dimension. Okay. So what is we left? A. A is LT minus 2. And what is T? T square. So what is we get? L. So you can see properly the dimension of this all are equal. So dimension of this and the dimension of this both are equal. Okay, both that all our dimensions are equal. So that is what only is saying we can add and subtract the two physical quantities only when we have a same dimension. That is the first quantity. Okay, that is the first property. So for example, let's take one example, then you will understand properly. Okay, so suppose take one example. Okay, suppose my V is equal to A plus BT. You have to find the dimension of A and B. That is my question. Then how will you do? How will you find the dimension of A and B? Solution. See, we know that whatever the quantity should added and subtracted, they should have the same dimension. So can I say the dimension of V should be equal, dimension of V should be equal to dimension of A. So what is the dimension of V? That is LT minus 1. And what is the dimension of A? I don't know. Let us, it is M to the power some alpha, because, or just leave it, don't write anything. So that should be equal to the dimension of A. So from here we get the dimension of A. What is the dimension of A? This is equal to LT minus 1. Clear? Similarly, you want the dimension of BT. is equal to dimension of BT. So just equate the dimension. What is the dimension of V? That is LT minus 1. Correct? This should be equal to, I don't know the dimension of B, but I know the dimension of T. That is what? T. So from here what you will get? My B is equal to again L2. Clear? So that is the dimension of B. You can find this in one more way. See, some people may think like this also. Some people, for finding B, what they will do, they can also say like that also. Sir, dimension of A is also equal to dimension of BT, because this dimension should also equal to this dimension. Now then only they can add. Yes or no? So we can say, what is the dimension of A? This is the dimension of A, that is LT minus 1. And what is the dimension of BT? I don't know. B, at the B dimension I don't know. T dimension is C. So from here also we will get the same answer, that is LT minus 2. So either you do in this way, either you do in this way. So both the way you will get the dimension of B as same, and dimension of A is very simple. Okay. Any doubt? Okay. No issues. Proceed further. Okay. Now next thing is, one more example. Let's take one more example. Some 80 plus BT square plus C plus DT square plus E plus T. Suppose this is the thing where X is equal to L, means the dimension of X is, or you can say where dimension of X is this, and the dimension of T, you know, T is time. So dimension of A, B, D, E. Okay, so you have to find the dimension of A, B, C, D, E. Clear? Just you solve this. I will write another question. One more question I will write. One more question. You solve this. Let me write one more question. It is JE previous year question. Okay, and the question is, P is equal to alpha by beta e to the power minus alpha t, where P is equal to pressure and T is time, and you have to find beta. That is the question. Just try it once. Try to dimension of alpha. You have to find the dimension of beta. Solve it. So if we solve this, I hope you have solved. So if we see the first question, in first question what it asked? It asked the dimension of A, B, C, D, and as I told you, whatever the quantity are added, they should have a equal dimension. So you can see here from directly here, see E and T both are added, so that I can see the dimension of it properly. Okay, I can say my dimension of E should be equal to dimension of T. So from here I will get my E dimension as T. Clear? Next is the first thing. See these two quantities. I can say this thing. If you see they are added together, na? So the X dimension should be equal to C dimension, because C dimension should be equal to X, or C dimension should be equal to 80, whatever you can say. So I can say one more thing. Dimension of C should be equal to, so dimension of what? Dimension of X. So from here I will get my C dimension as the dimension of X, that is L. So this is the dimension of C. Now another thing, I can say dimension of my X is equal to dimension of my 80. So from here I can say what is my dimension of X, that is L. What is the dimension of A? I don't know. What is the dimension of T? That is T. So from here what is the dimension of A I will get? That is LT minus 1. Clear? So for next we have find A, we have find B, E and C, then the next B. So I can from here I can again say dimension of my B, dimension of my BT square is again equal to what? Dimension of my X. So from here I can write what? I can write B dimension, I don't know. B dimension I don't know. What is the dimension of T? That is T square will be here, because there is a T square and that is my length. So from here I will get my B is equal to what? L T minus 2. That is the dimension of my B. So we have calculated A, B, C, and what is left? That is D. E also we have calculated. See, this is the one quantity. If you see properly, this will behave as a one quantity, one physical quantity. Okay, so this dimension of this whole quantity should be equal to the dimension of X or AT or BT or C, whatever you want. So let me, for the simplicity, dimension of this whole term, let's say this whole term is equal to something, you can take something A, B, C, D, something like that. Suppose I take it as some alpha. Okay, so the dimension of alpha should be equal to the dimension of, now whatever quantity you want, but I will write those quantity from which I can solve it easily. So I will take BT square, because from there I can solve it easily. Now let us see. So this thing, dimension of alpha is what? This is D. Then dimension of T is T square. What is the dimension of below thing? This whole thing dimension is T, because E is dimension of this whole thing. Don't add the dimension. T plus T is equal to 2T. No. Dimension of this whole quantity will be T. Now this thing is equal to, what is the dimension of BT square? B dimension is LT minus 2. That is LT minus 2. And what is the dimension of T square? That is T square. So from here what I will get? I will get my dimension of directly, and this T with this T will be cancelled. So from here if you see, the dimension of my D will be, this is L. Okay, so the dimension of my LT minus 1, sorry, this is LT minus 1. So from here we can calculate all the dimension of A, B, C, D, E, F. Okay, now the next thing, this is a JE question. See, for there you have to remember the approach. See, whenever there is a some E will be there. E is basically a number whose value is fixed, that is 2.18 something like that. This is a fixed number. So any number if has a some power m, this m should be dimensionless. It should not have any dimension, or you can better to say dimensionless is more better. It should be dimensionless. Dimensionless. So if it is dimensionless, that means I can say what you have to always do, you have to always do this thing. Dimension. You have to do only one thing. you have to always write dimension of M should be whatever the thing is there, you have to make it equal to 1. Simple. You have to make it equal to 1. As it become 1, that my work is done. So here what you have to do, dimension of my alpha t should be equal to 1. Now what is my dimension of alpha t will be there, alpha I don't know, alpha dimension I don't know, t dimension is t, because it is time, this would be equal to 1. So if you bring that side, it will be equal to t to the power minus 1. So from here you get the dimension of alpha. Now see, this thing is equal to this thing, set so that the dimension of this p should be equal to the dimension of whole this thing, but that this quantity is a dimensionless, because it is a number only, na? Number means constant, so this whole quantity will be dimensionless. Clear? So why it is if you put this value of alpha t to the power minus 1 here, and t value dimension of t will be t here, it will be cancelled out and it will become some number. So that's why this is a dimensionless quantity. So this is a number basically. So what you can say from here, you can say that my dimension of p should be equal to dimension of alpha by beta. What is my dimension of p? Dimension of p is a pressure. Pressure dimension I told, it is force upon area. Force, what we that is m l t minus 2, and what is area, that is l square. And what is the dimension of alpha, we have calculated it is t minus 1. So from here you get the dimension of beta, that is equal to how much? If you cancel out everything, it will be equal to m minus 1. If you bring m here and take it reverse, you will get m minus 1, and this will be how much? This will be l to the power minus 1, so it will become l, and this is t minus 1, that will become t. So this is my m minus 1 lt. That is the answer for this. So what is the dimension of beta here? It is m minus 1 l t. Clear? This is the answer. Any doubt? So this is how you have to solve the question of dimension analysis. Clear? Let's do one more concept and then we wind up. Basically one more application of dimension analysis. Another application is to check the correctness of the equation. To check the correctness of the equation. Clear? It is used to check the correctness of the equation. Okay. For example, suppose any equation is written, for example, like h is equal to some r rho g upon s cos theta, where what is r rho g formula you will learn in the liquid when we study about the liquids. Basically it is a equation of a height of capillary tube. So where r is the radius, rho is the density, g is the gravity, s is the surface area. Okay. So sorry, s is the surface tension. So what you have to, basically you have to find, you have to check whether it is a correct or not. Let's apply that. What is the dimension of radius? Again L. What is the dimension of density? Density is mass upon volume. So it is m upon volume, that means L minus 3. Now what is it? G is gravity. Gravity means acceleration. Acceleration is LT minus 2. So this will be LT minus 2. Now what is S? There will be 2 will be there. What is S? S is a surface tension. See, the surface tension is defined as a force per unit length. Okay. What is force? Force, you know, M L T minus 2. What is length? That is L divided by cos theta has no dimension, that I told you earlier, because it is a type of a numerical value only. Then 2 has also no dimension, so m0, l0, t0. Okay, so if you find it, what you will get, see, ll will cancel out, m will cancel out. From here 1t, this t minus 2, this t minus 2 will cancel out. This you, everything cancel out, you will get l minus 1, and this is l. So you can say my LHS is not equal to RHS. That means this formula is wrong. So from here I can say, from here I can say this formula is wrong. So can you tell me what I can do to make this formula correct? See, here we are getting L and here we are getting L inverse. So what will be the correct formula? So the correct formula will be what? It will be 2s cos theta divided by rho g. That is the correct formula. Okay. So that is a use of a dimension analysis. So basically we have learned today in the class, we have learned about what are the things we have seen. First we have seen, like what is my dimension, and we have seen how to find the dimension. We have solved some questions to find the dimension of different quantities like refracting index, universal gravitation constant, Planck's constant. See, don't stress about the formulas. That formulas we will as we started physics, as we go more in the physics, we will learn about all these formulas. Okay, so in starting, don't be afraid about this, because whenever they will ask the question, they will give you the formula. Then only they will, because they also know that you don't know the formula. Okay, so then after that we have seen this principle of homogeneity, and we have solved some questions on this. This is the very good questions. It covers all the concepts. Then we have seen last thing, that is how to check the correctness of the equation. Now in the next class we will see how to derive the equation from the dimension analysis, and what is the limitation of the dimension analysis. If you see, there is a limitation. See, if I don't know this 2n cos theta is there, then I will also get the same answer. Okay, suppose I remove this 2n cos theta, it doesn't matter for me, I will again get the same answer, but the formula will be wrong. Formula will be not conceptually, it will be wrong. But that is only the limitation of the dimension analysis. We will learn this in the next class. Till now, just revise this, and best of luck for your future. Thank you.